Recording has started.
So I would start out with that larger shape. In fact, I would make it a big rectangle like that, where we know that this is 50 millimeters. That's just the 88 minus the 38. And this over here is 40 millimeters. So my larger rectangle is 88 by 72. Which gives us 6,336 millimeters squared. But I have to remove that 40 by 50 right triangle. That's 40 times 50 divided by 2, which is 1,000 millimeters squared. So our total is currently at 5,336 square millimeters. Now we have to subtract out the pieces on the inside here. Well, they're not as difficult as they might appear. This is simply a parallelogram with a length of 44 and a height of 18. So that's just going to be 44 times 18. What is that, 792? Yes, millimeters squared. So we will subtract that. It was 4,544 square millimeters is our running total at this point. Next, we have to subtract out this last parallelogram that is 32 by 12. I believe that's 384. It is. So 4,160 millimeters squared is that area. So it's not near as bad as it looks. Any questions on that one? So then what I want to do today is I want to review our surface areas and volumes, have you guys try some, see how they're going. The first one I want to do can look like this. I can do better than that. So what we have here, let's call this a height of 10 inches. From here to here, we're going to call 8 inches. And we're going to call that 14 inches. Find volume and surface area. I'll give you a few minutes, then we'll go over that. let's see how this is going for you. So let's find the volume first. To find the volume, we need the area of the base. Our base is going to be split into two figures. One will be the rectangle. That is 8 inches by, the difference between the 8 and the 14 is 6, which means this radius here has to be 3 inches. So that makes that diameter 6 inches. So that's 8 inches by 6 inches, 48 square inches. Piece 2 is found by putting the two half circles together. That'll be pi times 3 squared. 28.26 square inches. We add those together to get the area of the base is 76.26 square inches. So then our volume is that area of the base, 76.26 square inches, times the height of 10 inches, for a volume of 762.6 cubic inches. For surface area, we already have the area of the base, 72.26 square inches. And it's going to go in twice because there's one on top and one on bottom. So then all we need is the lateral area. To do the lateral area, remember we need the perimeter of the base. So the perimeter of our base here, we have 8 inches. We have another 8 inches up here. And then we have the circumference of that circle. That circumference is just going to be pi times the diameter of 6. 18.84 inches. So we add that up to 34.84 inches is the perimeter of our base. So the lateral area is that perimeter of the base, 34.84 inches, times our height of 10 inches, which is 348.4 square inches. Add that up. I'm getting 492 square inches as my surface area. Any questions on that one? Okay, so our next one is going to involve a triangle. Our triangle here is going to be 21 inches, 18 inches, and 7 inches with a height of 12 inches. Once again, find the volume and surface area. I'll give you a few minutes and then we'll go over that one. Let's see how this is going. So we're going to look at the volume first. First step is to find the area of the base. Well, the base here is this triangle. That triangle does not have any right angles in it. So to find its area, the first thing we have to do is find the perimeter of the base. 7 inches plus 18 inches plus 21 inches gives us 46 inches of perimeter. Excuse me. From there, we're going to define the semi-perimeter, which is half of the perimeter, which is 23 inches. So the area with a square root of 23 times 23 minus 21 times 23 minus 18 times 23 minus 7. Huron's formula, if you recall. 23 times 2 times 5 times 16. Square root is 60.66 square inches. So my volume is that area of that base, the 60.66 square inches, times my height of 12 inches. Giving me a volume of 727.96. Cubic inches. There's my volume. You guys remember Huron's formula up here? Great. Now for our surface area. Well, we have the area of our base, 60.66 square inches, and of course it is one on top and one on bottom in this figure. We need our lateral area. Well, we already have the perimeter of our base as well as the 46. So our lateral area is that 46-inch perimeter of the base times the height of 12 inches. 552. Square inches. Giving us a surface area, 673.32 square inches. Well, the next one we'll have you try. Find volume and surface area again. We'll go over that one in a few minutes as well. So for volume, our first step is to find the area of the base. Well, this is, I should have labeled it, but we had to assume it was square, 14 inches by 14 inches. Which will be, what is that, 196 square inches. So our volume is the area of the base, 196 square inches, times the height of a 24 inches, but it's divided by 3 because it is a pyramid. So 1,568 inches cubed. Their volume. For surface area, got the area of our base is 196. There is only one of them on this figure. For lateral area, we have the perimeter of our base, 14 inches times 4, which is 56 inches. But we also need the slant. This is going to be 7 inches, half of our 14-inch side. This is still 24 inches of height. That slant will be found doing 7 squared plus 24 squared equals that slant squared, giving us that the slant is 25 inches. So our lateral area is the perimeter of the base, 56 inches, times that slant to 25 inches, divided by 2 because they all form triangles. 700 square inches. We add those together, total surface area of 896 square inches. Any questions on that one? Find volume and surface area for that sphere. This one's a little bit easier. Our volume is 4/3 times pi times the radius cubed. We're just going to enter that in the calculator. 4 divided by 3 times 3.14 times 12 cubed. 7,234.56. Millimeters cubed. That's a weird number, 2, 3, 4, 5, 6. For surface area, it is 4 times pi times the radius squared, so times 12 squared. 4 times 3.14 times 12 squared. Give us 1808.64 millimeters squared for surface area. The last one I want to try is one that people tended to struggle with a little bit when it was on the quiz. First, I'll be giving you different dimensions on the test. So let's say that we know that this is 10 feet across here. And we know that this is 60 feet and 100 feet. And of course, what we're looking for is the area of the track. I'll give you a couple minutes and then we'll go over this. Well, we don't have a lot of time, so we'll go ahead and go over this one now. So we're going to have 3 pieces here, actually 4 pieces, but they're going to come in pairs. Our first piece is going to be that rectangle that is 10 feet by 60 feet, or 600 square feet, and there are 2 of them. Next, we know that this radius here is 20 feet, And the inner radius here is 20 minus 10, or 10 feet. So what we're going to add to that is going to be a circle that is pi times 20 squared, which is 1,256 square feet, minus the inner circle that is pi times 10 squared, 314 square feet. We subtract there, we get a difference of 942 square feet. That's going to get added to our total up here. Here's a total of 2,142 square feet. Well, that brings us close enough to the end of class here. Once again, there is no homework, but tomorrow we will have test 2, will be the first hour of class. So there won't be any lecture during the first hour of class. You will have that first hour to work on the test. You have all day to work on the test, but I'm giving you that first hour of class as time to work on the test. Just so you are aware, next week, Tuesday, which is, what is that, October 20th, I believe? It is. There's an in-service. That means no classes. Next week, Tuesday. So tomorrow we'll work on the exam for an hour. I'll have it posted later today for you, so if you want to start early, you can. We will have 1 hour of lecture tomorrow to start off Unit 3. And then I won't see you again until Wednesday of next week. You guys have a great day. We'll see you tomorrow.